Hello everyone, I'm Juan Miguel Manaois, a graduate student under the program of Master of Science in Science Education, and this is the final requirement in the course Systems under the supervision of Dr. Kendra Gotanco Gonzalez. The lesson I chose is electricity, which is given in grade 8 science. So let us begin by identifying the learning outcomes in this lesson. Number 1, define the following terms such as voltage, current, resistance, power, electrical consumption. Solve problems involving the electrical quantities using Ohm's law. Third, understand the need for efficient electrical consumption in line with the United Nations Sustainable Development Goals. Fourth, reflect on the use of home appliances and how they affect our electrical consumption. And lastly, be compelled to make changes to daily home routines to reduce electrical consumption. In this final requirement, we are tasked to integrate systems thinking in any of the lessons in junior high school or senior high school science. We will make at least one causal loop diagram and one stack and flow diagram, which will be incorporated in any of the E's segment in the lesson plan. These are the E's in the lesson plan where the CLD and SFD will be demonstrated. Number 1, in the engaged part, it will reflect the causal loop diagram. In the explain part, the students and the teacher will demonstrate a stock and flow diagram. And in the evaluate or extend part, another stock and flow diagram will be modeled. Let us now go to the activity, materials, and procedures. The first model will be shown in the engaged part. The students will be asked to create a causal loop diagram showing the effect of electrical energy consumption on the temperature in the surroundings. Identify whether the CLD shows a positive or a negative feedback. The students will also use the following variables at the least: temperature in the surroundings, burning of fossil fuels, demand for electric energy consumption, emission of greenhouse gases, duration of use of air conditioning and ventilating appliances, and electric energy consumption. This is the sample or a possible answer or possible CLD model. It starts with the temperature in the surroundings. The higher the temperature in the surroundings, the longer the duration of use of air conditioning or ventilating units. Hence, it will lead to a higher electric energy consumption. Given that there's a high electric energy consumption, the demand for electric energy generation will also be increased. And as the demand increases, the burning of fossil fuel increases as well. And as we burn more fossil fuels, we are also increasing the emission of greenhouse gases in the atmosphere that causes the increase in the temperature in our surroundings. All in all, this CLD model shows a reinforcing feedback. The next E is the explain part. The class will solve the electrical consumption of a given appliance. Use the power and Ohm's law equations to solve for the necessary measurements or data. Once the electrical consumption of an appliance is obtained, it will be used in the computation of energy cost over time. This will be illustrated using Vensim via stock and flow diagramming. The problem that the student and the teacher will be discussing is this. Let us say that an air conditioning unit with a power of 935 watts and voltage of 220 volts is used for 2 hours per day. Solve for the total cost for electrical consumption with the unit of peso per hour on the 9th day. To solve this, you may use the equation below. First one, to get the electrical consumption, which will be in watt per hour or watt hour. Electrical consumption is equal to power or the wattage times operating time. The next one will be a unit equality to convert kilowatt hour to watt hour. 1 kilowatt hour is equivalent to 1000 watt hours. Energy cost is equal to electrical consumption multiplied by energy cost per kilowatt hour. Assume that the used power per hour is 935 watt hour. So we now convert 935 watt hour to kilowatt hour. We use the unit equality 1 kilowatt hour is equal to 1000 watt hour. So 935 watt hour multiplied by 1 kilowatt hour divided by 1000 watt hour. We do the unit cancellation and we will get 0.935 kilowatt hour. The next step, we will now use the value of power in kilowatt hour to solve for the cost of electrical consumption per hour. So the cost of electrical consumption is equal to 0.935 kilowatt hour multiplied by 9.4523 peso per kilowatt hour. This is the assumed kilowatt hour. Rather, this is the assumed uh, electrical consumption cost of electrical consumption per hour for that month. Let's say it is 9.4523 pesos per kilowatt hour. Then we get a product of 8.84 peso per hour. This is the stock flow diagram that the student and the teacher should model. So the flow or the appliance electrical consumption being the flow, wherein it will get a value of 8.84 and the unit is peso per hour. The stock will be the appliance electrical consumption, which will have an initial value or starting value of 0. This will be changing over time as long as the appliances or the appliance is being used. So the unit here is peso. So in this part, we can now get the um, energy cost on the 9th day of use of this air conditioning unit. So given that the unit or the appliance is being used 2 hours per day and we are tasked to get the value or the energy cost of the appliance or the unit on the 9th day, so 2 hours per day multiplied by 9 days, then we are getting 18 hours. So 18 hours for 9 days. And we use this table and time function of Vensim to see the time and the appliance energy cost. So we basically look for the time 18 and then we look at the appliance energy cost on the 18th hour, and that is equivalent to 159.12 pesos. So that is the total appliance energy cost on the 9th day of use, given that it is being used for 2 hours per day. So the last E can either be in the evaluate or the extend part. So I will be giving two problems here. So the first problem is a computer monitor powered with 0.176 kilowatt hour is used for 8 hours per day. How much would the device total or running energy cost be after 22 days of use? Note that the electric cost, or the cost of electrical consumption per kilowatt hour is 23.1 pesos per kilowatt hour. So let us now solve. First, we solve for the cost of electrical consumption. So we use the power, which is equivalent to 0.176 kilowatt hour, multiplied by 23.1 pesos per kilowatt hour, which is the energy cost in pesos per kilowatt hour. So we get the product of 4.07 pesos per hour. So we will be using this one in the equation in our stock and flow diagram. So this will be the stock and flow diagram. So our flow will be desktops or desktop monitor electrical consumption, and then our stock is desktop monitor energy cost. So for our flow, the unit will be peso per hour, and then the value, or the value that we will be putting is 4.07. So this is what we got from the previous computation. For the stock, the unit will be in peso, or will be peso, and then the initial value will be 0, since this is the we will be starting from 0 value, or 0 time, or 0 amount. And now we can get the desktop monitor's energy cost on day 22. Given that the desktop monitor is being used 8 hours per day, and we want to compute the energy cost on the 22nd day, so 8 times 8 hours times 22 days, it's equivalent to 176 hours, and 176 hours is equivalent to 716.32 pesos. And the last problem will be, consider the following information to solve the units, or unit X energy cost in 60 days with 5 hours of continuous use per day. The current is 4 amperes, resistance is 55 ohms, the cost of electrical consumption per kilowatt hour is 15 pesos per kilowatt hour. So this problem is actually a challenge problem, or can be given to students who would like to be challenged as they work on the equation of Ohm's law, power equation, and the use of Venn in showing the stock and flow diagram. So I'll just go through the slides as how the students and the teacher can solve this problem. So first, they need to solve for the power, okay, which is equivalent to 880 watts. So they need to this one, convert this to kilowatt hour. So it will be 0.88 kilowatt hour. And then solve for the electrical consumption, which will be equal to 13.2 pesos per hour. And now we can get we can illustrate our SFD. So unit X electrical consumption being the flow, and the stock is unit X energy cost. So our value will be 13.2 peso per hour for the flow, and for the stock is 0 as our initial value, and with the unit of peso. So now we get the unit X energy cost on day 60, and given that it is being used 5 hours per day, so 5 hours multiplied by 60, that is equivalent to 3,960. So that's it. Um, Thank you for listening. I hope you had fun and learned something. Bye.